Good afternoon, everyone. We are here for the Future Leader Technical Seminar. I myself, Ishite Arora, I am the FL Chair, and I'll welcome all the online members. Thank you for joining us. And I warmly welcome esteemed FLG Chair, Sir Shailendra Ram, who, though unable to join us in person, but is graciously attending the webinar. And yeah, he's there. Hi, sir. How are you? Cool. Okay. Now I would like to invite Sir Maqbool to kindly share a few words as a welcome address and his invaluable contributions to the Future Leader Forum, including mentoring all the young professionals and spearheading initiatives to inspire and empower the next generation of engineers. I'll welcome Sir. Please say some few encouraging words as a welcome speech. Thank you.
Right. Thank you, Ishita. That's quite an introduction. My name is Maqbool Mohammed. I'm a structural engineer based in New York City, at present American Society of Civil Engineers. As Ishita mentioned, I'm the deputy chair, assisting with the Future Leader Forum program. So just a little bit about the Future Leader program, Future Leader Forum, whatever we call it, and if you are in the program, you know it. This is aimed to offer some valuable insights, networking opportunities, and skill development for our young engineers. And then, with this opportunity, you're going to meet industry experts, academia, all the people that ASEC represents, which is about 17 countries now. So when you join as a future leader through this program, you get a valuable insight, opportunity to grow, learn, and be that leader of the future. It's not about becoming any engineer, just not an engineer or a manager. It's about the leadership skills. So it's a very active program. We have monthly meetings from, every month the members meet. We have active webinars. This technical session at each ECM is a big example for opportunity to come and speak. Including local, from M.SLRMES, other member countries are going to speak. So with that, I would give back to Ishita to introduce the speakers, and let's get into our technical sessions. Thank you.
Thank you so much, Maqbool sir, for such empowering and encouraging welcome note. And moving further, without wasting any more time, I'll welcome our first speaker, Engineer Lin from M.SLRMES, who not only captured the engineering, but has also been a part of the construction and project management. I would like to welcome him on the stage. Thank you.
Good afternoon, ladies and gentlemen, delegates and engineers from around the world. I'm Zeya, electrical engineering and Master of Business Management in Project Management and Construction Management. Currently working in Myanmar. I ran a small company in infrastructure development. Today I'd like to present environmental impacts of transmission line in ASEAN. I will just briefly explain the interconnection between Myanmar and other ASEAN countries. Our country, Myanmar, is the second largest country in ASEAN, 39 in the world by the land mass. We have vast resources in natural resources and renewable energy resources. As an electrical engineer, our country, we have an increasing power demand due to the development. But our generation capacity has to keep pace with those demand. That's why we have to increase our power generation and the transmission lines. As for the information, our country, most of the power resources are across the borders, which is the hydro, covering the 50% of the total installed capacity. Our daily demand right now is around 5.5 gigawatt, but the production is only 2.25 gigawatt only. So it means that we have less than 50% of the power supply. According to the 2023 data, our installed capacity is only 7.5 gigawatt, but due to various reasons and the challenges across the border, we cannot deliver our required demand. That's why we have ASEAN countries next to our countries, Laos and Thailand. We are building the cross-connection transmission lines to deliver the power required for our country. Right now, we don't have much existing transmission connection yet. Currently, we have a small power transmission line supplied from the Laos to the border city of Canton, Changdong. It's only 30 megawatt transmission line only. But we have two proposed transmission line projects from Thailand to Myanmar and Laos to Changdong again for the 230 kV line. Those two transmission line projects, we have expected to provide 600 megawatt from Laos and 1,200 megawatt power from Thailand, expected to deliver in 2040. So we need to build the transmission lines. There are some drastic effects occurring for our environment and the local communities, which I explained. Transmission lines, when we construct, we can make habitats to be fragmented, and those local wildlife species have to navigate for the surroundings. So this disruption may decrease the population over time, and we have a different stakeholder perspective on the wildlife conservation during the construction times. So we need to make an ecological consideration for the infrastructure developments. The biodiversity loss linked to the infrastructure developments, we need to make a community involvement for those biodiversity initiatives. Because those diversity is crucial for sustainable development in ASEAN, also in Myanmar as well. So balancing energy needs with conservation is essential for the ecosystem health. There are some challenges in balancing those development and conservation. The involvement of the local population in ecosystem health, it can be at odds with the transmission line needs. So we need to have protective measures for ecosystem integrity to ensure the survival of the diverse species. Secondly, we have socio-economic effects of the transmission infrastructure lines. Local communities, they often express concerns regarding building the transmission lines because their feedback is crucial for the project developers. If they disrupt our construction projects, we have several delays in financial and the project outcomes. Also, the installation of transmission lines can pose a health risk to communities, necessitating through the assessments and mitigation strategies. Also, we have to consider for their job opportunities and their local welfare, because building a transmission line can increase the job, but also after the transmission line, we can lose their income and instability for the local resident as well. There are some impacts for the cultural sites across our country's borders, which will lead to the resisting the construction of the transmission line projects. So we have to take care of the special care dealing with those kind of ingenious peoples. There is a special consequences which I want to highlight for the environment impact as well as the communities, which is those local communities near the substations and the power lines have a risk of cancer. According to the research done by IARC, International Agency for Research in Cancer, they have done the research in 2002, which is approved by WHO in 2007. It stated that we have a 200% increases of likelihood in childhood leukemia, those staying near the substations and the transmission lines. This is the radiation hazard, so this is very critical for considering the construction of the transmission lines. Most likely, I'm referring to those 230 kV transmission lines, which is the safety distance is around 91 meters. If not, there is a radiation hazard. The typical threshold of the human exposure is 2.5 mg, which I explain here is the safety distance for the 230 kV line transmission. The threshold is 40 to 75 meters. The safety distance is 75 meters and beyond. We have a legal legislation for the construction of transmission lines, which is the right of way. It's about 20 meters across the left and right of the transmission lines. This is the threshold. But basically, if we are staying in the safety distance, this is preferable. So how do we mitigate the strategies for environmental impacts? We have to integrate the environmental assessments into the designs. The construction of transmission lines, the design is the feasibility study is the most important after designing. We have to utilize the wildlife-friendly designs for the transmission lines. We have to engage with the local communities for their feedbacks to reduce their resistance. After that, after the construction, we also need to monitor what had happened to our ecosystem. This is very important because our country has previous examples. We've tried to build a coal power plant and the transmission lines. The local resident resisted fiercely, and our project has been delayed. And after much discussions and negotiations, still the communities hasn't agreed to our project. That's why the project has been cancelled. That's why the participation of the communities and monitoring the ecological impacts for the proposed construction is very critical for our transmission lines. So I here propose an innovative approach to limit the environmental impacts for the power lines. We should implement the underground transmission technologies near the urban area. And also we should conduct the pilot projects for the new technologies. And also utilizing smart grid technologies for the efficiency so that we can use the reduced line of transmission lines. Also investing in renewable energy sources, which we are currently promoting in Myanmar. Right now, in 2024, our current renewable energy and generation mix is only 3%. We are going to upgrade to 12% in 2030. So, how do regulate the framework for the transmission lines to reduce the impact? We will evaluate the transmission line impact on community first. What are their concerns regarding with the transmission lines? How do we collaborate with the local authorities and experts and the different stakeholder engagement in environmental assessments? According to the ADB EI assessments, we are generally for the transmission lines, we are currently in the category B. Sorry. We only need the initial environmental examination, i.e. only required. After this, we can go for the feasibility study and we can start designing the transmission line. This is how we analyze the impact matrix when making design for the transmission line. This is how we do the monitoring matrix. When we are trying to reduce the impact in construction of the transmission lines. So, to save our time, I would like to conclude. Our country needs increasing energy demands, so most substations and transmission line construction is inevitable. So we need to increase the awareness of the transmission line impacts on the environment and the local communities. To become awareness and to promote the benefits of the communities and preserve wildlife in construction lines of the transmission lines, we have to plan and design well. Also, we need to provide the monitoring and evaluation to mitigate the impact. Myanmar, in complying with the SDG goal number 7, 8, 9, we have to assess the energy and economic growth. We have to build the transmission and substation line. Of course, we have to monitor and maintain the environmental impact as well to comply with the SDG goal again. Thank you.
Thank you so much, Lynn, for giving us such an informative point and opening our eyes. What about the problems we are facing and everything? What are the mitigation goals? So I will open the stage for any questions. If you have any questions, yeah, I see we have a question.
Hello, good afternoon. Thank you so much for the kind presentation. It's very interesting as I've never thought about the electricity system in Myanmar, but I have several questions actually. So the presentation that you were giving is mainly about transmission.
Yes.
Transmission system.
Yes.
But you were also mentioning that there is a problem in the capacity.
Yes.
Of the production, I guess.
Yes.
But I was wondering, a lot of the transmission lines that you were showing are mainly for the planning on connecting Myanmar with other sources outside of the country. I think you were showing Laos and also Thailand.
Yes.
But are there any plans in the case of Myanmar to produce more from internally, like domestically, like
Yes,
new
we
plants
have
as well?
Currently, we have over 10,000 kilometer transmission lines ranging from 66 kV to 230 kV.
For the transmission line, but what
Yes.
about the production?
Production is
Generation?
Generation, we only have the installed capacity is around 7.5 gigawatt only.
Okay,
per
well,
day.
okay. And your demand is about?
Daily demand is 5.5, but
Oh, okay.
but our supply is only around 2.25 gigawatt per day, which is
Okay.
less than 50%. I
Yeah, it's,
mentioned
if you're saying your demand is about 5, but your supply is around 2.
2.5,
2.2. So
yeah.
it's less than 50%
Sure.
of the. Okay. Okay. So it means that you are expecting that with the connecting of the transmission line, you can have more stable supply
because
from outside.
most of our generation capacity plants are in the borders.
Okay.
So we cannot deliver power during this time. So we are thinking of another alternative power
Okay.
source.
I understand.
Yes.
Okay. Thank you very much.
Thank you.
Okay, so if there is any online questions, we are here to take one more question. Okay, okay, right, you can ask.
One question. You address the challenges with the community, address challenge with the production.
Sure.
How about the financial aspects, like investments? Like, what about the compliance or payment of bills and stuff? Do you have issues like that, like foreign investments, maybe? I don't know. So,
Building a transmission line across the country is, let's say, for example, if you want to sell me the power, then you provide me the loan first. Then after that, I make a meter grid. I pay you back monthly or quarterly according to the contracts.
right. Okay. Thank you.
Thank you so much, Len. Thank you for your valuable insights. Thank you. Now I would like to invite our second speaker, Engineer Hashan from Sri Lanka. He is a project engineer with Institution of Civil Engineers, Institution of Sri Lankan Engineers. So I would like to invite you on the stage.
Good afternoon, everyone. Thank you, Ishita, and the Future Leaders Forum of the Asian Civil Engineering Coordination Council for giving me this opportunity. So I'm Hashan Thilakarathna, representing Institute of Engineers Sri Lanka, and nowadays, currently I'm working as a University Associate for the Curtin University, Colombo, Sri Lanka, and so when it's come for this presentation, I was give the room to select any topic that I can work on. So this was one of my studies which I did my university undergraduate studies. So basically I will discuss about the influence of the polypropylene plastic aggregates on the mechanical properties of normal strength and high strength concrete. So moving for the today's content, I will basically discuss about these points. So for a community like you, I think you are engineers as well as most of you are civil engineers. So you know that what kind of crisis is out there in most of the developing countries regarding the municipal solid waste management. So it's the same as in Sri Lanka. So when it's come for this plastic waste generation, it's the second highest plastic type that waste type that we can found in the urban waste management systems. And when it's come for the different plastic types, HDPE, PET, and PP are the most common plastic waste types which is available. By considering the plastic supply chain in Sri Lanka, the virgin plastic production is absent in Sri Lanka. So the only way that we get plastic into the country is the imports. So when these imports were banned at some of the, especially the single usage plastic banning was there at the 2017, but when we refer the data, we show that it's also having some negligible impact on the plastic waste production, waste generation. So that's why it's high time to think about some alternatives that we can work on. By considering the global perspective, these are the current existing methods we use for the plastic recycling methods. Landfilling having a drawback, we need huge lands, and incineration releases a great amount of CO2, and recycling having a slow progression. So that's why as civil engineers, we try to incorporate this in concrete, this plastic waste. But there are both benefits and drawbacks. So benefits like we can prevent the natural resource extraction, especially the natural fine aggregate sand as well as the coarse aggregate gravel. So in addition to that, less material cost for the aggregate and reduces environmental impacts. When it's come for the drawbacks, weakening the strength, difficulties in regulating the quality, and the negative impact on the appearance can be given. So let's go into further. So when it's come to our study, we did it for a plastic sample we got from the Kandy Municipal Waste Council Plastic and Polythene Recycling Center. So when we doing the study, we understood that the polypropylene is the most common plastic waste available there, and the least recycled plastic waste on the other hand. So we choose that as our sample, the plastic type. So we are into the the aim of low substitution of polypropylene plastic aggregate in concrete. So so as similar to all the other plastic types, it has the favorable and unfavorable conditions for the strength and other properties. By referring to the past literature, we identified that there are two key objectives that we can set for our research. So we can think on what's the optimal replacement level, because according to the past literature, it's shown that it's like around 20%, not more than that. And the other hand, the application in high strength concrete, we can search for that. So this is kind of a summary of the past literature. So you can clearly see that it's mostly used as a replacement for the fine aggregate sand, and the optimum replacement levels are around 20%. And most of the studies are being conducted only for the normal strength concrete. So these are our objectives, determining the percentage reduction the compressive strength with this incorporation, and determining the both physical and mechanical properties, and finding the effects on the admixture, because nowadays most of the concrete is produced with admixtures to get more better quality. So we thought of examining that as well. So when it's come to our methodology, after the literature review, we had the material testing, because we need to ensure that our material is coincide with the relevant standards, and then we move for do different experimental approaches for normal strength and high strength concrete, and finally we have come to the conclusion. So this is the sieve analysis results for our fine aggregate and the plastic aggregate and the natural coarse aggregate. So when it's come for these, the two graphs which are right in the right, so the middle one you can clearly see that it also well within the ASTM limit for coarse aggregate, where it implies that we can replace our natural coarse aggregate with this plastic aggregate. But only thing is you can see there's a size difference between the nominal size of the plastic aggregate and the coarse aggregate, where I gave some negative impacts for concrete workability, where I discussed later. So with that, we can go with our hypothesis. We can replace our plastic aggregate, our natural aggregate with the plastic aggregate. So moving on. So these are the trial mixes that we derived for our C2530 normal strength concrete and C5560 for our high strength concrete. So when it's come for the normal strength concrete, first we tried without a superplasticizer, because for normal strength concrete we rarely use superplasticizers, because we can get the workability strength without a superplasticizer. But due to the kind of rough surface of the plastic waste, the workability was not achieved as we expected. So that's why we incorporate the superplasticizer, so where we can get the workability in the same time. When it's come for the high strength one, you know that it's really difficult to achieve the strength and the workability in high strength concrete without a superplasticizer. That's why for the normal mix as well as the plastic incorporated mix, for both we using the superplasticizer. This is the idea that I'm telling how we did the casting and the testing. So these were the standards that we used for the casting, and these are the tests that we use for the specimen testing. So for the testing, we have looked only three different parameters: workability, cubed compressive strength, and the splitting tensile strength. And these are kind of a summary of the results. So if you need any clarification, I can come back to this table and explain to you. So by going in deep for different type of strength parameters, so this explain about the workability. So you can see that there's a reduction in the workability with the incorporation of plastic waste in the concrete, similar to the normal strength concrete. In high strength concrete also we can see that reduction is there, but when it's come for the normal strength concrete, this reduction is prominent because we haven't included the superplasticizer yet, but here the superplasticizer is there, so the reduction is negligible. So, but since we need to take it to the range that we need, like 75, 100 millimeter range, we incorporated the superplasticizer, but it drastically increased the workability. So where we need some future studies, so why this like drastic increase is happening. So we should further study. When it's come for the past literature, there were some doubts in between a few researchers whether the incorporation of plastic waste increasing the workability or decreasing the workability. So we have concluded when the plastic waste is post-processed, like post-processing including heating and cooling, then crushing into the same size, same nominal size, the where we going to replace the natural coarse aggregate. So for example, if the nominal size of the natural coarse aggregate is 20 millimeters, so what we will do is we will get the plastic waste and then we will heat and then crush into the same size as the natural coarse aggregate. But when it's come for our case and some other researchers, what we have done was we have directly incorporated plastic waste as it is without any post-processing. So that's why it's giving a negative impact. So here the plastic waste is same as the natural aggregate, coarse aggregate, as well as the surface are smooth and rounded. But in our case, there was a mismatch between the nominal sizes, and on the other hand, they were rough and sharp. So due to these reasons, when the plastic waste is post-processed, we can increase the workability with this incorporation. But on the other hand, when it's not post-processed, we can't. There's a workability reduction that we should keep in mind. So here's the like how the like plastic incorporated the sample has been deviated. So I in blue color I have shown the C1 combined result for the entire the aggregate mixture, and in ash color it's shown the plastic incorporated mix. So you can see that in the coarser region, our the plastic incorporated sample is giving making a kind of a finer one, and in the other hand it has been become coarser. So there are some future studies need to be done regarding analyzing of these things. So when it's come for the compressive strength, we were trying to achieve the 30 cube compressive strength for the normal strength concrete. So successfully we could achieve, even though there's a reduction with the increasing the plastic content in the cement in the concrete. So however, we could not achieve the strength 20-day strength in the so high strength concrete. So there's kind of a conclusion that we have made. If we are using this plastic waste in normal concrete, yeah, we can achieve the strength. But if we are using it for high strength concrete, we should need further studies where can we need to study how much reduction is actually there. So because it's like a considerable amount that there's a reduction is there. So anyhow, like for both normal strength concrete and high strength concrete, the reduction is occurring due to this poor interchangeal zone in between the cement paste as well as the plastic aggregate. In here you can see that cement paste is there and the natural coarse aggregate is there, and there's a good bond since the natural aggregate has some pores in the surface as well. So there's a kind of a good hydration happening and the bond is there. But on the other hand, plastic aggregates are like hydrophobic nature, so which like means that it's not attract water, where it's reduce the cement hydration which can occur during in between this zone. So there are some more holes that can appear. So that's the main reason. So when it's come for the tensile strength, it also reduced with the incorporation of plastic waste, and the reduction can be seen in normal and high strength concrete. So these are our conclusions. So as I explained throughout the presentation, the workability reduction is there because we haven't post-processed the plastic waste, And on the other hand, by incorporating the superplasticizer, we can increase the workability. But when it's come for the normal strength concrete, the inclusion of the superplasticizer should be mindful because it was giving a drastic increase. And when it's come for the compressive strength, there are some determinantal effects. But when comparing to the normal strength and high strength concrete, the effects in high strength concrete is more prominent and should be more given more more further studies. And 20 replacement give the strength, but only for the normal strength concrete, but not for the high strength concrete. And these are our recommendations. So we need to check about the optimum dosage of the superplasticizer, and we should incorporate how we can do like appropriate compaction techniques for the high strength concrete, because there was a segregation occur due to the separation of the cement matrix and the plastic aggregate due to the less density. So these are our kind of recommendations, and these are our references that we have used. Some of them are here, and these are the publications. So if you are interested, you can visit my Google Scholar account and get some kind of idea. And that's it. And I should mention that most of the studies which was done at the Department of Civil Engineering, University of Peradeniya, and these are some of the authors which were involving in these studies. So yes, and again thank you very much for the Future Leaders Forum of the Asian Civil Engineering Coordination Council for giving me this opportunity, and any questions are welcome.
Yeah, please.
So maybe my question is, so you showed in the background that one of the reasoning that you wanted to make this is because of the waste problems, plastic. And I think you showed quite well that that it turns out that by using plastic you can achieve quite good, I think, workability as well, right? Like increase in strength as well. But my question is like, outside of your presentation, if you imagine to actually scale it up in terms of like factory production, or like actually using it to reduce waste, what are the barriers of your technology so far, like right now? What are the challenges in order, if you really want to implement it in like industry scale implementation? Thank you.
Thank you very much for the question. So when it's come for the challenges, we have done all the experiments, not only by our group, but also the most of the groups in the world also, they have done research for the mass concrete, not for the reinforced concrete. So we need further studies in that area. And in addition to that, we can't go this kind of a concrete for finishes, because the surface texture is not much appearing as the normal concrete. So our suggestion is we can go for like maybe flow concretes, not the finishes, but you know that after the first slab concrete, there are some flow concrete that we are putting to get the certain finish level. So we can go for that, because our suggestion is there, we can drastically reduce the structural self-weight by incorporating this one due to the less density of this kind of concrete. In addition to that, we can think on some precast elements, like maybe blocks where the structural loads are not appearing, just for partitioning we can use. And yeah, those are the...
So maybe I will rephrase the question. So actually the same problem also happens with, there is another thing that you can use for concrete, I think, by using, what do you call it, tires, yeah, right? So actually they, in their case also, they have exactly the same problem, that better not for like a column, for instance, not for beams, but just for surface streets, for instance, is okay, and all of those types of things. But I think more of my question is like, if I refer it back to the tire industry, it's quite clear that they have like a separate garbage separation system
that's
exactly for that, so that I can easily imagine how it's going to be mass produced by, let's say, collaborating with I don't know, a car industry or something like that. But in the case of this plastic, I think you have a specific plastic name. I'm sorry that I don't remember. It's PP20, right? So how do you imagine it being implemented, especially in Sri Lanka? Like, do you already have like a waste treatment facility where you actually separate this waste, this PP20, for instance, or are there any additional challenges if, for instance, you actually want to make it happen? Even I understand that you can only implement it with for certain types of concrete, but what is the challenge for that?
Yeah.
Thank you.
So when we were studying, when we were starting this study, we also thought that what would be the end applications. So, but very recently, I get kind of exposure. You know that INSEE is one of the largest cement manufacturing in the world, and in Sri Lanka also INSEE is there, and they are having kind of a sub-arm called INSEE EcoCycle. They are the largest waste management company in Sri Lanka. So we have that possibility because they have some kind of a plastic which can't be recycled. So anyway, there's a stock that they have maintaining. And on the other hand, they are the largest concrete and cement manufacturer in the country. So by this kind of research, that's why we need that university industry collaborations are required. So in such a thing, we can definitely make it happen. So until getting to know them, I also thought that there could be so many challenges when it's come for the plastic collection and all the other things. But there are some companies who do the both.
Yeah, interesting question and good answer. Actually, we have that problem in all South Asian countries where we are high waste generating countries, right? And the government doesn't support definitely, these programs, whether it could be waste management programs or promoting these alternative products. So, good initiative, good study, great. Thanks. Yeah.
Thank you so much, Hashan, for such an invaluable question answer round and for such invaluable information you have provided to us. Okay. So do we have any questions online or we can just move further?
I don't know about the time. Yeah.
Yeah, if we have like time, we can have one online question.
Any questions online?
Is there any questions online or we can move further? Okay.
Can I
So
have one
let's move
comment?
further.
Hello? Can I have one comment, please? Hello?
Hello, yes, go ahead, go ahead.
You can come over here and
The microphone of speakers is not we cannot hear the speakers. I cannot hear. Can you adjust the microphone of the speaker, please?
Sure.
Because
Others also have the
questions
same
and
problem?
comments are very valuable, but the
to
speaker,
register
I
the
almost
people.
cannot hear them.
I can hear you, Makbul.
Shailendra sir, are we audible to you?
Yes.
Yeah, okay. All right, we'll be a little bit louder, okay, from the next
Okay.
one. So,
Yeah.
thanks.
Thank you, Hashan. So next, moving on to our next presentation, that is, I'm presenting on RVS method for earthquake risk analysis. It's a basic study and the initial study on how the earthquake, this is the problem we are facing worldwide. So it is rapid visual survey for earthquake risk analysis. This is like in India, we have faced a lot of earthquakes in the past, but when we faced 2001 Burj earthquake, it actually opened our eyes. It actually gave us the platform to work for the stability of the structures. That is how we started building the BIS codes. We are revising the BIS codes over the years. So let's starting with that. Okay. So if we talk about the risk, Risk is directly connected with the vulnerability, exposure, hazard, and it is inversely proportional to the capacity. So if we talk about the vulnerability, as the vulnerability of a structure increases, it is in a vulnerable state, the risk of the earthquake increases. It does not require whether it is hazardous or it having a more exposure to the people, or if the capacity of the people is little less, it will again have our risk of earthquake. So if we talk about the rapid visual survey, it's a quick preliminary assessment body method to evaluate the seismic vulnerability of the buildings. We provide this RVS in two methods. One is a simplified quantitative assessment, one is a detailed quantitative assessment in this. So when we talk about the simplified qualitative assessment, we determine for pre-earthquake assessment and post-earthquake assessment of occupancy of the buildings. And when we talk about the detailed qualitative assessment for undertaking the pre-earthquake, it defines the structural typology of what kind of structure we are having in that area, what kind of material condition is there, the construction details, the architectural form. It gets into the detail of the structural construction, structure member construction especially, and which affects the degree of the damage in the buildings and post-earthquake assessment. So this also implies how we go with the simplified RVS method, as it contains the vulnerability mapping, which has the pre-earthquake risk assessment and post-earthquake damage evaluation, and based on the visual inspection rather than detailed structure analysis. This is the simplified RVS method, how we go to just the visual inspection rather than doing a detailed structure analysis. So importance of RVS is it is helping in prioritizing the retrofitting and strengthening of the buildings, which is the most requirement in today's world. It identifies the high-risk structures which may collapse during an earthquake. It has the leadership, the leaders which are working in the code making as the policy makers and in the team for the mitigation of such kind of structures. So in urban planning, disaster management and post-earthquake evaluations, we use the RVS method by the use of the mapping with the digital GIS mapping, with the drone system. We are going with this RVS method in detail and understanding the typology of different structures, different urban structures which are around us, connecting the urban and the rural areas. We are working with many of the, from the FEMA, ATC and IITs, IIIT, Hyderabad, NDMA has closely been working on these methods of RVS, and incorporated into national and international seismic guidelines. As I have told before that we are working with the BIS, we are working on the NBC codes for increasing the dead load and live load, which is the most important part when we do the structure analysis. And we have come up with a new codes in retrofitting for especially for the seismic analysis. We are working on it, and it's not for the public domain right now, but within 6 months, it will be available for the public domain as well. So application of RVS in earthquake detection. We have, like I was saying, GIS remote sensing mapping is very important for the high-risk zones. After the Burj earthquake, it has opened our eyes and we have been working tirelessly in the earthquake sector. We have some different forms also for RVS, which I'm going to show it. So this is how the RVS contributes to the earthquake prevention strategies. It provides data for the seismic retrofitting strategies, helping developing zoning regulations. Zoning we basically do for the urban planning, urban areas and the rural areas, which we are converting rural areas into the urban areas. They actually require much more their attention towards such kind of seismic activities, which comes into the zones like earthquake zones as per the Indian guidelines. Supports emergency response planning and evacuation strategies. So these were the case studies which we did before like RVS could come into the action, and it has helped us to building the Indian standard codes, increasing its values, because as we have grown further, we have seen the changes in the seismic activities, in the structural development. So this is how we actually go through the step one from performing a rapid visual survey. That is a pre-survey preparations, on-site inspections, scoring and classification with the help of all the checklists we have with the BIS code, with the FEMA. ATC is there. We have IIIT Hyderabad working on it. Data collection and reporting. Data collection, photographs, sketches, and GIS mapping. Generate risk scores and categorize buildings into safe, repairable, or hazardous ways. See, this is basically our form we have created for the RVS, having a different earthquake zones on the one side, and as per this code, we can have the detailed evaluation required, whatever the building is there, whether it is required a detailed evaluation, or we can go with the simplified RVS method. This we can also create not only for the earthquakes. We have n number of tsunamis there, cyclone is there. We have other disasters which actually occur, like man-made disasters are there, natural disasters are there. So same form can be created for the other different kinds of disaster. This is an example how we have with the occupancy, what is the soil type, what is the hazard which we actually occur in that particular area. With the help of the urban planning and GIS mapping, we can get to know where that particular building is there, what are the hazards which we are facing at that particular time. The tools and techniques which can be used in RVS, that is the guidelines, the FEMA guidelines, remote sensing, satellite imagery, and drones as we are getting into the AI development. So drone is one of the most easiest way to get to know the rural or the urban areas where it's difficult for a manual person to go and do the survey. These are the risk factors in RVS, like building age and construction material, structural system, foundation type, one of the most important, which actually depends on the soil type, and it is the basis of any structural buildings. In this RVS, I'm also only talking about the buildings, but yes, we can also consider these for the bridge engineering. We can also consider for the high-rise structures. We can also consider this for the high-span structures, large-span structures. This is just one area in the residential or the commercial buildings we are talking about. But earthquake takes a toll on each and every different types of building. We have, in this, if I talk about, we have the physical damage, we have the social damage, we have the economic damage. In this presentation, I'm talking about the structural and the non-structural damage only, because economy and social will require a lot of data from around the areas, which is the further study of this RVS method. So we were dependent on the FEMA 154 ATC 21, but now, as I have explained, like BIS codes we have generated for our Indian structure and Indian buildings, the retrofitting for the seismic activities, it has been upgraded. And since 19335 code, as every engineer, every earthquake person who have studied the earthquake know about these kind of codes. So this has been upgraded in the Indian standards. This is the risk categories like low risk, moderate risk, high risk. So several structural weakness, immediate intervention needed for the high risk structures, and moderate risk. We can help with the help of the retrofitting. We can actually safeguard our structure, which are in the moderate risk zones. These are the limitations and the challenges which we faced while doing the RVS, while going through this assessment and everything. And many in India, we cannot get to the typology of few of the households because many of the households are not even accounted for. We have so many houses which are not even comes under the guidelines that there has to be any structure. For these kind of structures, when the earthquake came, this actually creates a devastating effect on the lives of the people there. Again, we can enhance RVS with the modern technologies in coming years with the help of artificial intelligence, sensors, monitoring. When we talk about the policy recommendations does not only stop with the mandatory RVS, but like government initiatives for retrofitting of high-risk structures or national disaster preparedness program. These are all the things which we know that we have to do. But the most important thing as a structural engineer, if I say, is follow the codes while we're designing the buildings. Follow the codes while we're designing for the seismic zones. We have different seismic zones. We cannot compromise with the lives of the people over there. So this is the basic conclusion we have reached, that we actually have RVS method for the earthquake mitigation, risk mitigations. It should provide an emergency response and planning, and future advancements for in AI, GIS, IoT for the effectiveness of RVS. That is the rapid visual survey. And if I connect it with the seismic vulnerability mapping, which is we have developed, there was an old map, which I have already shown the map. That is the vulnerability assessment, which we have done for different kinds of buildings around the pan-India. So these kind of the problems which we are facing, we are not following the codes. We have developed the codes, but still it is not effective. So as the topic of this technical seminar is leadership, we have engineering, adaptability and development. That is lead in civil engineering. So leadership, we always require the policymakers to take a step when we are developing the codes. It has to be implemented, otherwise it is very difficult for us, for the engineers to work on it. And for the engineering, if I say that we have to follow the codes, irrespective of whatever is going on. It's an engineer's duty to build a structure within the stipulated codes. We cannot compromise with these kind of things, with such kind of disasters. And if it also depends on the population and everything, it is increasing day by day. We have to think it in the same manner. Adaptability is when the earthquake comes, what we do is we have the most important, the structures are your emergency structures, like hospitals are there. They have to be safeguarded. They have to be retrofitted in such a way that any disaster cannot be like, this is the most important part where everybody will be coming. The road infrastructure, we have to reach the hospitals there on time. Schools, when any disaster hits any city, if earthquake is there, the schools become the refuge areas for the people. So these three are the main line areas, line structures are there, which has to be built within their stipulated codes and with all the regulations has to be followed. And with the new development, we always look forward that with the good material and the construction strategies, we should work in the same, work in the safe environment. Thank you. So if there is any questions regarding this.
Just a comment.
Yes, please, sir.
Just a comment. I think the last item that you touched on, which was the implementation, I think is very important to come up with development and enhancement of these tools.
Yes, sir.
But and then incorporating them into the codes for structures, buildings, other things like that. But the key, like you said, is in the implementation.
Yes.
I'm actually not in the structures area. I'm from the water side, and I remember I'm originally from India also, but I've spent most of my life in USA. So in 1972, or if maybe it was in 1970, that I think it was 1970 that India adapted the Water Pollution Control Act, and so did the United States had their Clean Water Act. Okay, of course, US has a lot more resources. So they put their efforts in implementing that act. And I think India has lagged behind in the implementation of the Water Pollution Control Act. We have seen enhancements in water quality in the US during these last few decades. And only now in India there has been some improvement. So fast forward to this other in the area of earthquakes or other tools, and I think organizations, non-governmental as well as governmental, need to focus more on implementation, while the scientists and technologists are developing better and better tools. So,
definitely, sir. Definitely, that is our aim to achieve. Yeah. Thank you so much, sir, for your
Any
comment.
other questions from online or here in the room? I have one. RVS is a great tool because I'm also on the bridge inspection side. We have a very similar kind of a inspection method, very quick. But one of the challenges I see, I know you mentioned all the risk and challenges. RVS tool, I believe, when you have a built environment where it's a mixed type of, one are seismic vulnerable buildings,
Yes.
and there are few that are already seismically retrofitted buildings. So you have a mix of them.
Definitely.
So this tool doesn't differentiate, if I'm not mistaken, right? Unless you have the data. And I believe that data in countries like India is a big issue, that which buildings are safe, which buildings are not safe, and the proper implementation of the RVS.
Yes. That's why we have divided RVS into two different categories. That is, one is a simplified RVS. That is only with the visual and getting to know about the building. We do the pre-earthquake and post-earthquake survey. One is a dignified, and it's a whole lot of, detailed qualitative RVS method, in which we do the typology of not only the buildings, also around the areas. That's why it's come under urban planning as well. What is the architecture form? What is the sitting architecture form is there? Which is the soil is there? What is the foundation is there? So all these things comes under the detailed RVS. So that's why from there we can actually get to know what kind of building is that.
And all this data is stored on the government websites, or where is this?
Yes, they are for the public domain as well, and even the vulnerability risk resilience index is also there on the public domain. Whatever the changes are there in the building codes, within a 6 months or a year time, that will also become available on the public domain.
I see one comment from Shalendra. RVS will assist with early detection of risk, allowing for implementation of preventive measures. Do you think RVS are more cost effective than post-disaster repairs? Encourage you to provide evidence for cost effectiveness.
Okay. RVS are cost effective than post-disaster repairs. Yes, we are working on the same things. Like, as I've told, this is a physical evidence data which I'm collecting, but with the data and the socio-economic data, we can work on this, like we can get to know about the cost-effective, how it is cost-effective, and what areas or the niche areas it is actually required. So we can work on it.
Yeah, to answer, I think Shailendra is both ways.
Yeah.
The RVS helps in deciding what should be repaired or not, but also at the same time, RVS has limitations. You cannot do structural analysis based on the RVS data.
Yes.
Okay, so you need a detailed assessment.
That is the limitation.
So it's both. So, and whatever you implement, it's, I don't know if it's cost effective or not, but most of the time I think it's cost effective because it eliminates the need for detailed analysis for most of the structures.
Yeah, because the detailed analysis is actually needed if we have to go with the RVS. That is why we have developed the detailed RVS method, where we are actually going with each and everything from the starting to the bottom. It will contain all the data of a building. We're trying for that also. That's why we are making a little bit small changes in our codes. I know it is a very slow work which is going on, but it is actually going to be effective.
No, I mean, this is a great presentation for, especially in current situation in Myanmar, actually, because, and I believe tomorrow we'll be speaking more on this, actually, so. Thank you.
Thank you so much, everyone. Okay. So next, I would like to invite Engineer Chaw from FedMES. She will be giving a detailed presentation on earthquake in Myanmar. Welcome, sir.
Good afternoon, everyone. Good afternoon, everyone. Thank you for all being here today. Firstly, I would like to introduce myself. I'm Engineer Chaw. My background is civil engineering, and I'm specialized in water resources engineering. Now I'm working as a part-time lecturer in SDM Myanmar University, and also I'm working as a water supply and sanitation consultant engineer. Today, I would like to present about the overview of earthquake in Myanmar. This is just overview knowledge, not in detail. And actually, if we were to slide through our art, it will resemble like an orange. We have our continent, and we have sea, and under the sea, we have the seabed. So under the seabed, our art is like this, outer shell, and then media layer. Under the media layer, we have upper mantle, and the lower mantle, and innermost layer. So our shell is about 50 miles thick with temperature around about 79 degrees Fahrenheit. And then upper mantle is about 250 miles thick with temperature around about 1600 degrees Fahrenheit. And then lower mantle is about 1800 miles thick and with temperature around about 7000 degrees Fahrenheit. And the innermost layer is about 800 miles thick and with temperature around about 9800 degrees Fahrenheit. So our outer shell is always in motion because of the intense heat and movement in the liquid rock layer below. So this movement is what causes earthquakes, volcanoes, and drifting on continent over the millions of years. And now I would like to present about the earthquake-prone place boundary. The earth where the edges where earth tectonic plates collide, push against, or slide past each other, are where earthquakes frequently occur. Generally, there are three types of plate boundary. The first one is divergent boundary. They are pulling each other. And the second boundary is the convergent boundary. They are colliding each other. And the third one is the transform boundary. they are sliding past each other. So there are 3 boundaries. These boundaries are also where fault line found. And as an aggregate zone, on our art, there are 2 major aggregate zones. The first one is the Pacific Ring of Fire. Pacific Ring of Fire. There are 2 aggregate zones. The first one is the Pacific Ring of Fire. This is the encycling to the Pacific Ocean. And the second aggregate zone is the Alpine Himalaya belt. This is stretching from Europe to Southeast Asia. So Myanmar is located within the Alpine Himalaya belt, Alpine Himalaya belt. This is making it prone to our earthquake. Now I would like to share the seismic zone in Myanmar. Myanmar seismic zone can be classified into the 4 zones. The first one is the western zone. This is from Arakayuma to the Chinhe region. And the second zone is the central part of zone. This is we call the Sakai Fault area from north to south fault line. And then third one is the we call eastern zone. This is include Shan Plateau and eastern mountain ranges. And the fourth one is the Gulf of Myanmar offshore zone. This is located under the ocean. Now I would like to share about the Myanmar historical earthquake. Throughout the history, Myanmar has experienced a lot of destructive earthquakes. In this earthquake, I would like to highlight some of the most significant events. In 2011, we experienced with Thali earthquake. Thali earthquake with the intensity of 6.8 magnitude and 8 km depth. This earthquake is due to the strike slip around an east-west trending fault. As an aftershock earthquake, there are lots of numerous follow-up tremors are recorded. Due to this earthquake, a lot of buildings are damaged and collapsed. And then, 2012, we also experienced with the Beijing earthquake with intensity of 6.8 magnitude and depth is about 13.7 km. And this earthquake is also due to the Sakai Fault along north to south trending fault. And there are a lot of numerous follow-up tremors recorded as an aftershock. There are a lot of aftershock earthquakes. Due to this earthquake, a lot of buildings and a lot of structures are also collapsed and damaged. And then, 2016, we also experienced with Bagan earthquake with intensity of 6.8 magnitude. The depth is about 84 km. This earthquake is due to the Gabor, we call the Gabor fault, and aftershock persistent at low intensity. Due to this earthquake, ancient pagoda are sustained as a structural damages, and minor damages are observed in the residential building. As we all know, recently, 28 May 2025, we experienced a kind earthquake with magnitude, with intensity of 7.7 magnitude and 10 km. This is the biggest earthquake in Myanmar during the 100th year. This earthquake is due to the Sakai Fault along on the north-south trending line. There are a lot of aftershock, numerous follow-up tremors are recorded. Due to this earthquake, a lot of buildings, roads, and bridges are collapsed and damaged. Here, I would like to appreciate each and everyone and every country who are supporters and giving hand to all of the Myanmar people affected by destructive earthquake. Actually, earthquakes themselves do not harm people. It is the construction of buildings that are not earthquake resistant that causes harm to people. According to the references, in 2024, there were a total of 19 earthquakes worldwide with a magnitude of 7 or higher. More than 64,100 people lost their life due to earthquake in 2024. So I would like to explain about the types of building in Myanmar. According to the 2014 census, Yangon region, the most development area in Myanmar, has 42% of its buildings are constructed from wood. According to the schedule, we have the list. There are 23% of apartment and condominium, and there are 9% of bungalow and brick house, and also we have the 42% from wooden house and 12% from bamboo house. So in the past, residential houses were primarily built using lightweight and flexible materials such as wood and bamboo. Starting from the end of 19th century, there was a shift toward the stiffer and heavier material like brick, mortar, and reinforced concrete RC. So, earthquake forces depend on building weights and flexibility. Therefore, heavier and stiffer structure experience greater seismic impact compared to lighter and more flexible one. Now, I would like to explain about the Myanmar earthquake zone map. The Myanmar earthquake zone map displays the maximum potential of seismic display. Myanmar earthquake zone map displays the maximum potential of seismic intensity expected across the different regions of the country. We classify with different three colors. The yellow color area may be experienced with low intensity. The magnitude may be between 1 to 4. And then yellow area can be experienced the moderate intensity. The magnitude can be between 5 to 7. And the red area means the high intensity. The magnitude can be between 7 to 9 area. So we have the Myanmar National Building Code 2020. Now we are also trying to upgrade Myanmar National Building Code 2025. According to the Myanmar National Building Code, we calculate the seismic design requirement according to this flowchart. So according to the building type, we calculate the response, importance, and responses. And according to the soil data, we also choose the site class and we calculate FU or FB. And according to the building type and soil data and ground acceleration, we calculate CS. And according to the building weight W, we also calculate the earthquake forces. And then we design the seismic design and we make the necessary seismic design requirement. We already have the earthquake design flowchart in our building code. Now, I would like to explain about the disaster risk. Disaster risk depend upon the hazard exposure and vulnerability. As our previous speaker also mentioned about this hazards, and now I would like to explain a little. Hazards mean hazards is a natural or human-induced event. Is a main earthquake or flood or cyclone with potential to cause harm measured by intensity or frequency. As an example, a magnitude 7.0 earthquake is a hazard. This all we all know. And I would like to explain about the exposure. Exposure means people, assets, or systems located in hazard-prone area that could be affected, including building, infrastructure, population of ecosystem. So, as an example, a village built on an active fault line is exposed to the earthquake. And I would like to explain about the vulnerability. The vulnerability is the sustainability of exposed element to suffer damage due to the hazard driven by factors like poor construction, poverty, or lack of preparedness. As an example, a low-resistant infrastructure may be vulnerable to collapse during earthquake or due to the weak material. Therefore, the earthquake is also a hazard. Hazard depend on the exposure and vulnerability. Earthquake is a natural phenomenon that we cannot be avoided. Therefore, we can reduce the exposure and we can try to reduce the exposure and vulnerability. For reducing vulnerability, we can try to enhance the public awareness and we can try to develop effective early warning system. And then, for the reducing of the exposure, we can try to implement systematic urban planning system, and we can try to avoid constructing at the high-risk zone. Now, I would like to present about the key measures for the earthquake preparedness. The first one is building earthquake resistant structure. So we need to follow engineering guidelines to ensure building can withstand the seismic forces. And we need to use reinforced foundation or proper steel framing and seismic damper to absorb the shock wave. And the second one is retrofit the older building. We need to strengthen weak wall, column, and foundation in the existing structure. And the third one is the public awareness and education. We need to contact aggregates and promote the drop, cover, and hold-on techniques. And we need to teach excavation route and emergency response procedure. And the fourth one is the emergency preparedness. And we need to establish clear excavation plans and emergency medical support system. And we also need to establish clear excavation plans and emergency medical support system. And the fifth one is the government and community collaboration. We need to implement national seismic safety regulation and clearly warning system. We need to work with geologists and engineers to monitor the earthquake risk. These are the key measures for earthquake preparedness. So as a conclusion, I would like to highlight that Myanmar is located in earthquake-prone zone, making it vulnerable to the seismic hazards. So earthquakes are natural phenomena that we cannot be avoided. However, constructing buildings with earthquake-resistant design can significantly reduce potential damage and risk. And with when earthquake strikes suddenly, preparedness and resilient infrastructure can save life and minimize the destruction. Therefore, I would like to highlight in our presentation that we need to prioritize earthquake-resistant construction and public safety today. Thank you for all. Thank you for all attention. I will be here your thoughts and questions. Thank you.
If anybody has any questions, we welcome the questions from the audience.
Chat.
Is there any question online?
I don't want to be the same person asking the question, but I will ask if no one has any question. Anyone? You showed the formula where risk is equal to hazard into exposure.
Into, hazard.
So I have a little with exposure, right?
Yeah.
Now, by giving that exposure, which is like basically you're telling like, you know, all the risk is there. So should we add something like, I would say is criticality index, something like, for example, to say that, hey, all buildings in this area should meet this standard. We cannot achieve that in certain countries. So maybe certain critical infrastructure like hospitals, then maybe those are the ones you prioritize. You talked about prioritization there. Maybe that should be a first step for some of the governments and some of the countries on the high risk zone.
Yes,
do you agree, or what is yours?
Yeah, we agree. Yes, therefore I would like to highlight also, I would like to also highlight the awareness and early warning system. Yes, therefore.
Yeah, I agree.
Okay, you mentioned the past history of the big earthquake in Myanmar, right?
Yeah.
So, but I would like to learn what are the lessons learned from those big earthquakes, and then what has been done to improve either the building code or other parts of the.
Actually, the recent earthquake is about 7.7 magnitude. This amount of earthquake we have never experienced. This is the earthquake during 100 years. So the recent earthquake are not more than 7, about 6 to 6.4 like this. So from this earthquakes we learn we need to design more earthquake resistant structure, and we also need more public awareness.
Yeah, but I'm talking about the lesson learned from the past earthquake. I think starting from there, and then you can build up your capacity. I mean, like in Taiwan, we also learned from our Chichi earthquake, and it took us more than 10 years to kind of convince the government to implement the scheme and retrofit all of the school buildings. And it took another 15 years to do that. So things like this. Yeah.
As for me, the lesson learned from the past Aggregates is we need to design more seismic resilient structure infrastructure, and we need to enhance our community public awareness.
Yeah, so I would suggest that also focus on the lesson learned, and then also try to find the evidence that after we improve the safety of the structure and so on, and then you can show people that, okay, that's the right direction to go, and then you can get the society and also the government to support further action. Yeah, that's my suggestion. Yeah.
Thank you for your suggestion.
Can I ask a question? Okay. I'm Thorsten. I'm from the engineering side. So you mentioned about the Myanmar have a lot. The presenter is also mentioned. Myanmar have a lot for experience, a lot for earthquake, but we need to focus on the building as well as on the public awareness. But on the building side, if you make according to the regulator always mention that building have to make a earthquake resistant building, but in real situation they are how can I say that they are
not follow.
They are not follow. Yeah, they are not follow in real situation. Yeah, because as according to the cost, they also consider the cost estimation. Yes, when you put seismic resistant building, the building cost will be higher when compared to the normal one. That's why most of the people don't have earthquake resistant building because they don't have awareness about the earthquakes. That's why they consider about the normal building just like that. And also during March 28, I was at the Naypyidaw. The earthquake is very high. It's just like most of the building is falling because I was there at Naypyidaw. Yeah, as you know, most of the government office also they don't have put any earthquake resistant building. They don't have the sign about they don't consider about the earthquake. That's why most of the government resident building always almost collapsed. Yeah, at the time. Yeah, that's why I would like to mention is we need to focus on the regulator to focus and to follow the earthquake resistant building to make that something like that. Yeah.
Thank you for your suggestion.
Thank you. Yeah, I mean that's a great experience you said, right? It's just I think at the end is a combination of all the things because you could have a great building that is earthquake resistant, but what if there is no roadway? There is no road for the people to get out. So how do you? So it has to be a network level, like buildings, schools, hospitals, roads, everything eventually. But to your point, yes, the compliance, code compliance, and the awareness, that's very important, definitely.
Yeah. For our country, it's
it
the most
is.
important.
Yeah. For all, pretty much every country in or going back to India too, like in Bhuj, right, the earthquake there, like Yeah. So a lot of lessons learned. Still more to learn. I think there is more to do, definitely, on this. But thank you very much. Appreciate it. Yeah.
Thank you.
Thank you so much, Sue, for such an informative slides.
There might be one question online. Let's see the chat.
Oh yeah,
please.
let's see. There is any question? No. Okay.
All right. Yeah, that's Shalendra. Congratulations to all 5 future leaders for their excellent presentations. Well done.
Keep on working on your problem. Thank you so much, Shalendra sir, for such nice words. Thank you. Okay. So if we don't have any questions, let's conclude the session. So we all have like different topics, different genres of the civil engineering we have. That is the main essence of this technical seminar, to being the lead in the civil engineering, bring all the topics at one platform in civil infrastructure in totality, and to understand the issues which we are having in our civil engineering domain. And congratulations to all the speakers. They have spoken very well about the topics. Okay. So now, gracefully concluding today's session, I would like to invite Sir Maqbool to our esteemed Deputy Chair of our FL group, Future Leader group, and to share a few words of wisdom. And after that, we will have a group photograph with all the speakers. Thank you.
All right. Like I mentioned at the beginning, this was the idea, to just invoke thought process in young engineers. You saw great 4 presentations, 2 of them touching the real topic that we face today in this country and other countries nearby. Right? So this is the idea behind the Future Leaders and these technical seminars. People who have participated, thank you very much. This is, hopefully, you got a little bit of introduction of how Future Leaders work or what we do actually. So thank you for people online. I know we are from different time zones. And I always say this Future Leaders thing, our monthly meetings and seminars, almost all 17 countries participate from different time zones, from US to Japan, right? Unlike the ECMs, where majority of the people are in person, our Future Leader sessions are mostly online. And it's a challenge for all the Future Leaders who are attending. So thank you very much. I appreciate it. Yes, so we have this tradition, we take the picture at the end. So for the online participants, if you can turn on the camera, everyone, I think we will, I'll invite everyone to come over here and we kind of take one picture. Yeah, and I would request you to actually, yeah, thank you. Yeah, just we will stand in front of the screen. Maybe, and I think that should cover pretty much everyone.